This is Mrs. Yamasaki, and in this section we're going to do the examples that's on the worksheet that was given to you on solving quadratic equations by finding square roots. So for the first example, when you're trying to simplify a square root, what you're looking for are numbers that has a perfect squared factor, like 4, 9, 16, because square root of 4 equals to just 2. Square root of 9 equals to just 3. So those are the kind of factors we're looking for here. So if you think about 24, it does have a perfect square factor. It happens to be 4 times 6. And because this is multiplied, we can actually separate it into its own square root. And again, you notice there's the square root of 4, and we know that the square root of 4 is just 2. Now the square root of 6 doesn't have a perfect squared factor, so we can just leave it inside the root. Now for example B, again, we could multiply these numbers together, but it makes the number very big, and to find factors can be very difficult. So the best thing to do is just find a pair of factors that are squared numbers. So looking at 18, I know, let's leave the 5 there, I know that I can split that up as 9 times 2, because if I split that up individually, again just change the order here so we can see it a little bit better, we can actually square root the 9, and square root of 9 is just going to be 3. And then again, 5 and the 2, even if we put it together, there is no perfect squared factor, so since they're both underneath the root, we can go ahead and put that together as the square root of 10. Now for example C, when you have a fraction that is square rooted, we can actually separate that as the individual on the top and the bottom. So I could write this as the square root of 9 over the square root of 64. Again, looking at these numbers, these are perfect squared numbers, so we can change that to a 3, and the denominator becomes an 8, so our final answer is 3/8. Now when it comes to rationalizing the denominator of the fractions, remember the idea here is to actually try to simplify the denominator. If we look at the square root of 7/3, we know that this is going to be square root of 7 over square root of 3. And again, square root of 3 is a irrational number that becomes a decimal that basically doesn't repeat. So we like to actually simplify that by just multiplying it to itself, because we know that when we have, so we want to go ahead and multiply the bottom again by square root of 3, because if we multiply that to itself, because it's squared, we're looking basically for a pairs of numbers to multiply that out. But again, when you're transforming a fraction, you only can multiply a product of 1, so you also want to multiply the top by square root of 3. Multiplying straight across, 7 times 3 will give you 21, so that becomes square root of 21. And then when you actually multiply the bottom, we know that's the square root of 9. But again, we know the square root of 9 is just going to be just 3. So that would be your answer for this problem. Now for example B, what you have to be recognizing here is the denominators. It happens to be a binomial, and it actually has a root. So it's an indication, one of the techniques that you can use here is to actually multiply it by the conjugate. And remember, a conjugate is where you basically have the binomial where the sign in between the two terms are the opposite. So in this case, I'm going to go ahead and multiply it by 5 minus square root of 3. Now again, same rule applies. It's a fraction, so you want to multiply it with the factor of 1. So you want to go ahead and multiply the top by 5 minus square root of 3. At this time, you have to also recognize that now all we're doing here is distributive property. So for the top, we're going to multiply 4 to the 5, which gives you 20, and then multiply 4 times negative square root of 3, which is 4 square root of 3. Now for the bottom one, it's a binomial times a binomial. So you want to go ahead and follow the rules of distributive property, or shorter known in this case, FOIL. If you do remember the differences of two squared numbers, you can just right away write it as 25 minus 3, which is 22. Or if not, you can always write it out by following the FOIL method. So putting it to the side here, we have 5 plus square root of 3 times 5 minus square root of 3. Again, first thing we do is 5 times 5, which is 25, Then you want to do 5 times negative square root of 3, which is negative 5 square root of 3. Then you want to do the inside, so square root of 3 times 5 is positive 5 square root of 3. And then you do the last one, which is square root of 3 times negative square root of 3, which gives you negative square root of 9, but if you simplify that, it's just negative 3. And you notice the reason why we do this conjugate idea is because the two terms in the middle cancels out, and that gets rid of the square root. So now we have 25 minus 3, or simply 22. So let's go ahead and put that number down in the denominator. And one of the other things that you want to also be sure is that your fraction is simplified. So be sure that when you're simplifying fractions, that when you have something that looks like this, that the terms on the top, so in this case both of them, there's two terms on the top, is factorable or can be reduced with some sort of a factor from the bottom. Now 24 and 22 actually all have 2 in common, so we're going to go ahead and divide out 2 from 20. That gives you 10. Divide out 2 from negative 4, which gives you 2, square root of 3. Now remember, you cannot divide the numbers on the outside with the numbers on the inside. And then the bottom one, 22 divided by 2, will be 11. So this is your simplified version. So when it comes to solving a quadratic equation, what you have to remember is that we want to actually remember that we want to isolate anything that says a term squared. Now in this case, we notice that the binomial is squared. So if you don't see any other variables in this, that's not, for example, y, what we can do is actually use this method of square rooting on both sides. So what we want to do is isolate anything that has a term squared. So we want to go ahead and get rid of that 1/4 first, so we can isolate the squared term. So we're going to go ahead and multiply everything by the reciprocal of 1/4, because that's the one that we want to get rid of, and which becomes just a 4. If we go ahead and distribute that to the first part of the equation, because it's all multiplication, 4 and 1/4 cancels each other out. So that leaves you with y minus 6 squared. And again, we also want to make sure that we multiply 4 with the 8, because this is an equation. You want to be sure that you do the equality property for both sides of an equation. So this becomes 32. From here, you can go ahead and square root both sides. This becomes y minus 6 equals plus or minus square root of 32. We go ahead and add 6 to both sides. And let's put this over here. So we get y equals 2, 6 plus or minus square root of 32. But again, you want to be sure that your final answer is simplified. And so we notice that 32 is not really simplified. So if we go ahead and think about 32, we can actually write it as 16 times 2. That would be your best choice, because if we go ahead and split that up, we know that 16 just becomes a 4. Square root cannot be simplified, so your final answer would be 6 plus or minus 4 square root of 2. Now you have some checkpoint problems. Go ahead at this point, you can either stop the video and try it yourself, or if you have already done it, you can go ahead and scroll ahead and see if you get the same answers that is on this slide. So again, if you have 5 times square root of 10, we could go ahead and split up 10 as 5 times square root of 2. We know square root of 5 times square root of 5 is just 5, because again, if you go back, square root of 25 is just 5, and then we have square root of 2. For number 2, again, if you have a fraction with the square root, we can separate it as square root of 9 over square root of 11. But we can go ahead and simplify square root of 9, so that becomes 3 over square root of 11. Again, the point of this particular problem is we want to rationalize. So we're going to go ahead and multiply square root of 11 by something that will get rid of the square root. So your choice here would be square root of 11 over square root of 11. Multiplying straight across, you get 3 square root of 11 over 11. And the final practice problem here, again, we want to isolate the x squared. There's no other term that has a variable like x, so we can go ahead and use the method of square rooting on both sides. So we're going to go ahead and add 16 to both sides. then you get 2x squared equals 250. Divide both sides by 2, then you get x squared equals 225. We square root that on both sides, and remember, whenever you square root a problem on both sides, you always want to write the plus or minus sign. So in this case, the final answer is plus or minus 5.